Well, thank you all for being here and for having the endurance for the second half of this doubleheader. So I appreciate it. I recognize I'm competing with Bumgarner and Kershaw, so I very much appreciate you all. But I want to thank the MAPS committee for organizing this, and for Linda in particular for giving what's just a brilliant run-through of how this great crisis is also an opportunity. And so, while I will also continue the trend of kind of depressing you a little bit, what I'm hoping comes out in the next bit is to really talk about the wide range of solutions that we have to this issue. And again, without saying the punchline and then saying go home, I just want to highlight what I really think is the key part of the message here. And that right up front is that while this looks like a massive problem, and it is, it's also one that we're really well armed with solutions. And as much as climate change and our energy system and the health and environmental and the food impacts often look like and are often talked about as a technical issue, kind of something where physicists, chemists, engineers are really driving the show. And as a physicist, I like to think that this is really a social choice. And the technical opportunities are there. They get a lot of the press, but they're really the tool, not the driver. The driver is the kind of take action, talk to your mayor, representative, assemblyman or woman, senator, congressman, etc. That's the story. And the tools are critically important, but they're just that, they're tools. And so what I'll try to really talk about today is the degree to which we're actually very well armed to deal with something that looks overwhelming, but when you break it down to the various issues, it is not as challenging on paper as it appears. We have lots of layers of policies and behaviors and political connections that make this problem look overwhelmingly hard, but in fact, we're in pretty good shape to solve it if we only wanted to. And that's really the take-home. So now I guess you can go home. But that really is the key part of the story, and I'll try to illustrate that with a number of examinations of what we know and what our options for solutions are. And if anybody wants more on the materials that I'll talk about, the website of my laboratory, it's called the Renewable and Appropriate Energy Lab, is at the top. It does have the typical mix of technical scientific papers, but it's also got videos and things that we've made, sit-down discussions with the Pope, discussions that we've done with members of Congress, with heads of state around the world, with community groups. There's also a Twitter feed, which at the bottom is listed. For those of you who do that, my daughter made me start to tweet. It was a little bit challenging. But even though it's listed as my name, it's actually a place where we do about one tweet a day or one tweet every other day about what's going on, what's the latest events. Next Friday, President Obama and Premier Xi will sign a critical agreement that I'll talk about in a second. But it's really designed to be a website that is much, much more than an academic site. It's got movies. We've recently produced something called Time to Choose, a movie that'll be in theaters soon. A television series called The Years of Living Dangerously that hopefully some of you have seen, that we've worked on. A variety of much more accessible material. So I'll try to use that as the basis for a conversation. And I will start out with the technical, kind of the nerdy summary graph, because I want to contrast two things. The science and how we talk about the science. And when you saw in Linda's slides the data about the climate effects on health and on food, and popular books like Merchants of Doubt that really describe the politics, I want to give you kind of a similar picture of that story here. And I won't flip back and forth between the two slides. I think I'd be doing this all the time through. But if we think about this from a technical engineering perspective, the path that we're on in terms of observed climate change is really this history of emissions. Like I said, we'll do a little bit back and forth. And then this orange, reddish line here, that business as usual, if we don't make the change that we know we need to make. And I'm going to contrast that dramatically increasing greenhouse gas emissions line That's the path that we are currently on. And then this blue line here where we bend that curve over and we cap emissions, it's really the triangle that's defined between the two of them that we're talking about tonight. And when Linda showed the graph of how much carbon we've burned so far in the form of coal, oil, and gas, and the growth of the clean energy economy, it's really the difference between this upper line and this lower line. And it's really a triangle, or we often say a wedge, of change that we need to make. And there's lots of things that can go into contributing to shaving wedges off of that triangle. Investing in cleaner energy. You heard Linda talking about the health and also the climate benefits of investing in using public transit that needs to work properly, and not just for the affluent, but for all Californians and all people of the world. Investing in solar or wind or other technologies, they contribute to bringing this down. And what you hear a lot, and you'll hear more and more about after the major climate conference that happened in Paris, is the difference between being on this business as usual or really unacceptable pathway, and the pathway down here, and then the impacts that go across climate systems, health, ecosystems, all things that Linda highlighted so clearly, all of which have really significant impacts on us. And what the climate science community has adopted is to say that there is no line in the sand. It's not if you're above a certain number, you're in dire straits, and below it, that you're perfectly safe. But that roughly 2 degrees of warming is a separation line between costs and risks and damages that we can't even conceive of dealing with, and then a set of reduced but still serious risks below that line, this roughly 2-degree guardrail, as it's called. And one of the really heartening things that happened at the annual climate meeting that took place in Paris in December was that the United States and several other countries, many developing countries, Australia, a number of others, stepped forward and said, we're reading the science. The doubt is really over. We know we need to act. There will always be clutter in the media, and there's always going to be debate about things because this is the most complicated system we know. But not only is this 2-degree line something we have to aim for, but this group came together and called itself the High Ambition Coalition, saying that 1.5 degrees is really where we're going to need to be headed. And that's a really important change, because what it's done is taken the climate debate and it's framed it much more like something that we know in the United States. In the US, the most successful piece of environmental legislation has been the Clean Air Act. And the Clean Air Act, in its current form, is several thousand pages long. It's very complicated. In the initial version that was passed, it was 100 pages, and it basically said something very simple. To the extent that we learn new science, and to the extent that we have cost-effective technologies and practices, we need to keep making the air cleaner. Not a certain number, not above 2 degrees and we're in dire straits at 1.999 and we're fine, but that we need to simply keep bending that curve. The Clean Air Act has improved the quality of lives for Americans across income levels, across where they live. It has been an ongoing process, and it's one that doesn't have a simple endpoint. It's not we get to a target and we're done. It's that we keep improving based on the cost-benefit trade-off. And that is not an easy, sound, biteable piece. And that's one of the challenges. The climate story has not been an easy sound bite to say, hit this number and we're set. So what I'm going to describe is really the range of things that we know we can do, the areas where we need to do more research, where we need to do more education, where we need to get more community and individual engagement. But it's actually a very, very hopeful story. But our entire history of investing in one set of technologies, largely, but not only fossil fuels, makes the future that I'll talk about today, and that Linda highlighted so eloquently, challenging, not because we can't do it, but because we are advocating for something which is inherently unknown and hence risky, as opposed to what we know how to do. But that's the change that we have to make, and that's again what I'll try to illustrate as we go forward. In terms of the science, we've already seen very clear increasing temperature and sea level rise, and California were quite addicted to discussing the amount of snow in the northern hemisphere. We have less data there. This was a good but not crisis-solving year in terms of that. But I want to contrast this picture that comes from my background as a physical scientist. I'm a physicist by training, where if you're here versus here on the graph, it makes very little difference. If you look at this just from an analytics, here versus here, the story is kind of equally clear. Admittedly, back here, that bump, what's going on with some different years where things go up and down, it's a bit hard to see. But when you get up here where we are now, the science isn't changed much year to year. But let me run through the strongest statement the international community of researchers was able to make over time. So when the first global assessment was done in 1990, the first assessment report by this group, the IPCC, that shared the Nobel Prize with Al Gore. So there were several thousand of us that did that work. There was one Al Gore, so I guess we're all micro Gores. But the strongest statement that the scientific community could make and could then get adopted by all the governments of the world, no small task, was to say it's going to take us another decade to really sort this out. So, full employment for this group for another decade. The second assessment report, not many years later, the science has barely changed. If you look at those vertical lines, it said the balance of evidence suggests discernible human impact. Talk about it's a tortured statement. This word took 8 hours to negotiate. Discernment. So you can see how hard the barrier is to get the new language in front of us. By the third assessment, there it is, the third assessment report, the TAR. See, science hasn't changed much. Most of the warming in the last 50 years is due to human activity, and it gives a probability. The fourth assessment report, again, science hasn't changed much, but there it is in terms of this growing consensus. Most of the warming is very likely, 90% probability, due to human activity. And then this very rule-bound group, the IPCC, representatives from around the world, must get through government filters, made its first critical, normative, or forecast-based statement where it said, warming will most strongly and most quickly impact the global poor. Didn't say just Central America and Kenya, places where I work. It said the poor worldwide. My wife is a physician. She works at Oakland Children's Hospital, and she routinely treats people where the emergency room is their first line of medicine. That's what we're talking about here as well. A crisis where we will leave the poor behind, and we already see it in the form of many of these illnesses. And then special report on renewable energy came out. It's an interim report. It said we could decarbonize or get rid of that 80% of carbon emissions. And then there was an if. And this is like a computer programmer's nightmare from the 1960s. It was an if-then statement that said, if we do this, if we do that, 100 pages. It said it's possible, but it's going to be a challenge. The most recent report that came out for this Paris Climate Conference said we are 95% or more confident that this warming is due to humans, and that if we take this challenging path of making this transition, we will be able to change the system. In 2014, perhaps the most significant event happened, where the two countries that contribute 40% of global energy demand and 40% of greenhouse gas emissions signed a side deal, often called the G2 agreement, where President Obama and Premier Xi said, we are going to step out of a very complex negotiating process and simply say the two of our nations will commit to as rapidly as we can to change this picture. What they agreed in 2014 was not aggressive enough to make that 2-degree guardrail I showed you come true, but it took the two countries that were arguably the slowest moving of the major economies and it moved them from laggards to leaders in this process. Next Friday, on Earth Day, President Obama and Premier Xi will sign that agreement into effect. And the way the rules are written, 55% of the world's emitters have to agree to ratify the agreement. That's something that never happened for the Kyoto Protocol, which was the prior agreement over 15 years ago that never came into effect. Some countries in Europe signed it. The US sort of moved along but didn't actually do it. Canada signed it, but then they discovered Alberta and discovered they had to back out of it because Alberta was a bit of a problem. And so this agreement on next weekend is going to go from 0 to 40%. Europe has already said they're going to sign on. So the Paris Climate Accord, which sets the numbers I've described into effect, is going to be put into ratification now in less than a week. And that's a remarkable step forward. It's lots and lots of commitment to act. It doesn't mean we are going to act. There's still ways to back out just by doing what Canada did, for example. Not to pick on Canadians, although let's pick on Canadians. But it sets up a very different frame to think about the opportunities. And just so we know how severe the global story is, this is just a map of energy demand around the world showing very small growth in the US and Europe, some growth in the rest of the world, India being a big piece, but recognizing that international partnerships, so after China, will dwarf energy growth and greenhouse gas emissions if they and we in partnership don't find ways to really bend that curve over. And so this successful outcome at Paris, a complete change of the optimism around this process until very recently, really changes our opportunity to think about putting what California has done and is doing into a global leadership position. And I'll talk about many of our policies as we go, but it's changed the dynamic. This is kind of the detailed, sciencey version of the story that I just described, but let me do something a little different. One of the challenges is, as clear as the science is to experts, it is a complicated process. So I'm going to show you an 18-second video that you can download from NASA's website that gives just one example of what we're seeing in the world. And what I'm going to show you is data. No models, no forecasts, no complications about what might happen in the future. This is just going to be satellite observations of the North Pole. And the pictures you're going to see stitched together to make a movie are taken at the point in the late summer when the sea ice is at its minimum extent. And that just illustrates what happens year to year. Now that means it's not the same day because sometimes that minimum sea ice comes in late August, sometimes early September. It's a function that varies year to year. But let me just kind of show you what this is going to look like. So this will again just show the amount of sea ice over the North Pole. And it started out at about 6.5 million square kilometers in the summer minimum in the late 70s. So the years go up and down. There's lots of wiggle room to say, oh, we had a cold year, so we're fine. We had a warmer year, so we're not so fine. But if you look at the overall trend over just a few decades, we go from the 6.5 million square kilometers down to half of that just a few years ago. That dramatic difference, this is all observation, no modeling, no simulation. This is causing incredible changes, not just in the Arctic, but with the food available for fish, marine mammals. We're seeing changes in currents. This will highlight how dramatically, in this period of time, we are changing this overall system. So that's the bad news. What I want to talk about, though, is the good news. None of it is easy, but the opportunities are really dramatic. So that this is the same picture I started off at the beginning with that red line, that business as usual. The commitments that nations made leading up to the Paris Climate Conference brought that global average temperature warming down from 4.5 to 5 degrees. And by the way, 4.5 to 5 degrees of average temperature can mean up to 20 degrees at the poles. Melting, for example, the Greenland ice, that would cause 23 feet of sea level rise in just Greenland ice melts. Down to the commitment level around here, still leaving this triangle of commitments and actual actions. And commitments are a lot easier than actions that we would need to get to change the story. The good news is that commitments made by countries having witnessed this signing by US and China and seeing the process in Paris have now probably brought this line down to here. That's basically commitments to stopping this dramatic rate of growth, but cutting is going to be the challenge. And that's really where we're going to talk about for the rest of today in terms of things we need to do. Now, I too want to talk about the smoking example, because often you hear these climate stories as if it's just a lost cause, it's so difficult, it's the whole world system. But we really do have a situation where we have seen, in some areas, dramatic changes. We go back to when GIs were issued cigarettes as part of their rations during World War II, to talk show hosts, cartoon characters, smoking, doctors smoking, presidents smoking, actresses sometimes together smoking, and a whole variety, I guess, anyway, we'll leave that on the side. But I want to highlight things that my kids say, were you really that stupid? We understand these health effects, but did we really actually ever do this? Where the plane was 70% non-smoking, but I guess we thought those smoke molecules didn't migrate around the cabin. And we were even stupider than just having smoking in the back and non-smoking in the front, but then we had non-smoking in the front of first class, and then smoking, and then non-smoking. You look back and you say, could you really be that idiotic? It's easy to say that after the fact. It's hard to make the changes in time. This was not, for those who lived through it, a simple change to make. But when you look back, you realize how tied to practices of the past we were. Now when we walk by those glass smoking boxes in airports, and you see it's like a great cloud in there, and you say, how would you ever want to go in there? And yet, people still go in there, right? For a variety of reasons. So these changes are not a simple thing, and don't think just because the technologies are there that our behavior will catch up. But it highlights how available these changes are to us. And again, in the US, it has been a dramatic process where warning and labels really highlighted how significant it was in terms of the costs, the different levers from warning signs to taxes to other issues about airplanes and public places and not selling to minors, all the things that Linda highlighted, that this has been a huge success story. Not fully solved, and we all know when we travel around the world, you can find places where the rates of smoking are remarkable, but this also highlights a worry. We have until roughly 2050, roughly mid-century, to shave and bend that curve down, and yet in this case, it's decades long, and we do not have those decades left. So what we're going to need this time is going to be a much more aggressive and fast transition than we've seen from these issues which looked hugely insurmountable at the time. But when you look back and say, yeah, I can see the health effects, I can see the damages, and yes, we all have someone, maybe some of us, most likely some of us who still smoke, but we really see the impacts. The climate story is going to have to evolve at a much faster rate, and that's really the challenge. We have other examples where we have actually been fixing environmental problems at a remarkable rate. It really harkens back to the clean air story. We're now going to have to apply that in a new area. One example of this, and an area where the science community has done an absolutely terrible job, myself included, is really to find ways to visualize our greenhouse gas, our carbon footprint. And I just want to illustrate an example of something that takes this global issue and makes it local and really highlights many things that you heard before in terms of what are the immediately available local opportunities to change. So one example is this coolclimate.berkeley.edu website. It's one that actually Governor Schwarzenegger asked our lab to build. There's another version. It's called coolcalifornia.org. It's the same site, but one is managed by some state organizations, and this is the one where we do kind of the research side. But what I'll highlight is that on this website, there's opportunities to go in and do a carbon audit, if you will, for yourself, your business, your school, and to see where are carbon emissions, both physically out of the top of a building, or carbon embedded in the goods and services that we buy. And those are quite insidious. It's easy to point your finger just at a coal or gas or oil fired power plant, but less clear to say, well, what's the carbon embedded in my laptop? Meaning, what's the carbon that required to make it? Wherever that was emitted, whether my laptop was made in California or China or elsewhere, where's the energy? What's that process? And so this is an example of a site where you do your audit, you put in your electricity bill, where do you live, it tells you what are your impact. And then here's an example of something which we added kind of as a lark at the end of the story, but has proven to be really interesting. So after you do your audit, then it will spit out this list of things that you didn't say you did. You're not driving the most efficient car. You're eating a very large amount of meat, whatever else it might be. And it tells you if you made that additional change, buying a more efficient vehicle, telecommuting, how much you would save in carbon and whether it would cost you or you would save by making that change. And here's a version where this person has said, I commit to do these particular items on that list. Not doing every one, but sort of picking and choosing the ones that person wanted to do and see what effect it would have on one's lifestyle. What you see here is that each of these measures, except for this one down here from this particular person, would all save them annually and over 10 years a really significant amount of money. And so this highlights the economic savings as well as the carbon savings. So of course, when you have data like this, you can make maps out of it, and we have a version which is one of those maps. You roll your mouse over and you can see the numbers. And here's an example. So this is the carbon dioxide emitted for the average household in each zip code around the country. Some areas we didn't have enough data, but you can see the map, and it's clustered largely around urban areas where there's just more driving, more transport. If I kind of click through, here's the carbon footprint of the goods and services, the Amazon.com and the other purchases that come to our house in terms of delivery trucks and various things. Services we get. If I zoom in on 4 cities, just to kind of highlight something, zip codes are interesting, but zip codes average over pretty big areas. And zip codes in rural areas are not that many people. But if you zoom in on cities, and I've chosen 4 cities here, all of whom have won awards for how green the city's plan was. And yes, even Dallas has won significant awards for having a green city plan. But if you look at each of these cities, what you notice is that they often have, well in each case they all have, a relatively low carbon core, the greener, lighter colors. And then they have what, if you will, kind of a suburban shadow, right? Kind of a 5 o'clock shadow of carbon emissions. And yet each of these cities have won awards for investing more in public transit and doing this and that, but they left suburbs out of the story. But of course, the economic vitality of these cities is a mixture of the urban core and the suburbs. And so one of the issues is really knowing your carbon footprint. And what's fun when we do versions of that with this website, of course, the first thing everyone does is to go look at their zip code. And it's just incredibly illustrative to see what are the emissions. In each area, are you more emissions from driving or from the energy supply or goods and services? And it really provides a way to kind of learn up and see what they are. And as Linda said, unlike most of the country, transportation is dominating our emissions here because electricity in California is relatively clean because of the wide range of practices that we've adopted. And while we've done a lot on transportation relative to other parts of the country, we simply drive a lot compared to other parts of the country. So I'll highlight some of that as we kind of go through. The good news is that California already has examples where we've been able to bend that curve. And so this is electricity consumption per person going back to the 1960s. And while you can see California in the US, many people think, well, nice climate, California would be lower than everywhere else. In fact, back in the 60s, we were a little bit higher because we want to protect our environment. California set up new agencies, passed a number of requirements to be more energy efficient. And what we've seen is that those practices, better light bulbs, requirements for efficient water heaters, recycling water, a whole variety of things have meant that in the industrial sector, California shaved off a fair amount of emissions relative to what we've seen in the rest of the country. In the commercial sector, we've shaved off even more by requiring better and better practices. And the same thing in our residential sector. So much so that energy use per person in California didn't keep growing like the rest of the country. It leveled off. Economic theorists, energy assessors in the 1960s literally said over and over again, if you don't grow the energy use at a given rate, you cannot grow the economy. It's simply not possible. And in California, 8th largest economy on the planet, did that separation. And this should look just like that graph I described in the beginning, with that business as usual versus the flattened out path. Now, don't get too happy here, because this is energy use per capita, but we've added a lot of capitas. And so we have challenges here like everywhere else. But this highlights that that kind of dramatic change is actually a possibility. In fact, California's climate law, the so-called Pavley-Nunez bill, or somewhat grandiose title, they hate it when we say the title outside of California, it's called the California Global Warming Solutions Act. Little grand in title, but right on target. And what it said is that the black was our history of emissions, this is just relative to the baseline year we used to calculate, 1990. We were growing in emissions. That's the business as usual. California's greenhouse gas bill said, bend the curve, cut from our peak by about a quarter, and bring us back down to that 1990 baseline by 2020. When this was passed in 2005, it looked like a monumental challenge. We were only a few years out of the energy crisis, the electricity crisis. California is now ahead of schedule to get back to that baseline. That's the great news. The bad news, of course, is that getting back to the baseline is just kind of zeroing out the equation. And from there, we need to do that dramatic cut. That roughly 80% reduction in emissions by about mid-century for that 2-degree target. That's basically like saying we need to have a new, clean industrial revolution in the next 3.5 decades and do what it took 150 years in the first place, but now do that in not 15 decades, but in 3. So the challenge is massive, but education is the beginning. So let me highlight, this is a box that's meant to represent what California's emissions would be in 2050 if we were on that business as usual path. And what I'm going to say, of course, is exactly what I just described, and that is we need to reduce this box by 80%. How is the state thinking about it? And California is one of the go-to places. Every single city, state, country, even examining this, sends delegation after delegation to California to study what's happening in urban areas, in agriculture, in statewide planning, in partnership with neighboring states. Not perfect, but a very interesting picture. And there's 2 axes. One is we can choose fuels that are dirtier or cleaner. So obviously we're going to be choosing cleaner fuels. So we're going to take this box, and the final box will have to be crushed down from the top. And then there's a mix of fuels for our vehicles, gasoline, biofuels, and other things, and electricity. And because we have some of the cleanest electricity in the country, because of our investment in solar, wind, biofuels, and I'll talk about hydro and nuclear in a second, this box is going to have to shift away from liquid fuels, whether they're fossil, or biofuel and shift over. And so the picture we're talking about is to start off with this box here, to be more efficient, to use less of everything. That's kind of step one. Electrify, shifting off to the right, using cleaner and cleaner fuels, shifting down, being left with this target down here. This communication process, which experts thought would be incredibly complicated, is actually something that you ask any California legislator, those that are on board with this transition and those that have real reservations, whether they agree fully or not. This description of ending up here is now the dialogue in the state. And that has been a difficult challenge, but that communication is in many ways more critical than the really interesting and vital technical and policy changes that I'll describe as we kind of move in the last bit of the talk. So just to put it in perspective, California's path first was to say, let's dramatically clean our electricity mix by, in every opportunity, switching from the dirtiest fuels, generally coal as the dirtiest, to natural gas, to renewable energy, and making that shift. And there's lots of complications in the accounting. What's cleaner and what's dirtier? That's a whole field in itself called life cycle analysis. But when this was first passed, California committed to getting 20% of our electricity from clean sources by 2010. We missed that target, and we threw a party and said, yeah, we missed it, but we made a lot of progress, we bent the curve, we got there. By 2020, our plan is to be at 1/3 clean energy, and we are ahead of schedule. And as you heard from Linda, 2 of the 3 elements of what's called Senate Bill 350, 3 different 50s. The first 50 is to make buildings 50% more efficient. That passed. The second one is to make our electricity 50% from renewables by 2030. That passed. And the one that has not yet passed, but I believe will pass this coming year, is to reduce our liquid fuel, our fossil fuel consumption in vehicles by 50%. That has been a big challenge. And it shouldn't be a surprisingly big challenge. I'm pleased we got 2 of the 3 last year, and I believe that with this process going forward, we'll get there, but it depends on all of us. In California, we've said that large hydro no longer counts as a renewable. States all vary. I'm from upstate New York. In New York State, they count large hydro as a renewable, largely purchased from Quebec. We have decided it doesn't count because we have lots of people, we value agriculture, we value trying to put water back in the ecosystem. So we've said our target is one that won't permit it. And we've also said in California, until there's a safer and more affordable strategy to manage nuclear waste, we also won't count that. Those are 2 biggies that location by location around the US and around the world, there are debates about whether large hydro should be in or out, whether nuclear should be in or out. But California, as one of the world leaders, has committed to one without those 2. As an example of the most remarkable transformation that we've seen, this is describing the change in price of what was used to be the most expensive renewable and how much we've deployed. So this is going back to the 70s when solar photovoltaic electricity was several dollars per kilowatt hour. And just to remind us, for the students who don't pay your utility bills directly, electricity in California, if you are a conscious, not over-user, costs about 10, 11 cents a kilowatt hour. If you use a lot, you can pay up to 30 cents, but we'll leave those electricity hogs aside. And the price has now dropped so much that the cheapest forms of new power you can install, cheapest in the US right now, are solar and wind. I want to repeat that because there are industry executives who just simply don't believe it, because how could that be? The cheapest contracts for new large-scale utility scale power plants in the US right now are solar and wind. It's not natural gas, it's not nuclear, it's not coal. It is solar and wind. That doesn't mean the story is won. It means we've made huge progress. And in fact, the amount of solar has risen so much that around the world, there's about 65,000 megawatts, or 65 gigawatts, or roughly 65 big power plants worth of solar. Turns out that number is almost exactly the peak demand in California on a hot summer day. So this is all around the world, but solar has gone from a totally insignificant player to now equal to the energy demand of the 8th largest economy on the planet. Hasn't been easy, but a remarkable transformation. Now, why just getting the price down doesn't mean that the world will shift over is that if you want to take advantage of the best wind locations, the best places for solar, some of it on our rooftops, and who has solar on the rooftop? So that is the wonderful, heartwarming California story. There's lots of reasons why the rest of us should have solar on our rooftop, but there's also arguments why, because you're a renter or because of shading or this and that, you don't. But we're ultimately going to have to be in a place where basically every building has solar on the roof. But this transformation really describes how much time, how many challenges it was, but also how possible it was to flip that equation. But just getting the price at or below the price of fossil fuels doesn't solve the day, because the places with the best sun or the best wind don't, of course, have transmission already pre-built to them, so we can't get it all to market. So there's lots of other economic stories that have to be fought, but this should really make us proud. California and Japan and Germany and Bangladesh and Kenya are the places that have been on the leading edge of making this story happen. California's plan going forward, you can see we've always had a fair amount of geothermal and biopower and a fair amount of wind that's growing, but it's really this new wedge of solar, both distributed on rooftops, whether it's homes or businesses, or large-scale solar, as you see here in Southern California, that is really forecast now to be this big transformation. Now, this is a really heartwarming story of a technology getting cheap, getting distributed, but the buildings, the individuals, the companies that have been able to install most of this is not representative of the population. As solar dropped in price, that was partially because we did more research on the technology, but also because of programs to subsidize and encourage deployment. Because every time you build more, companies jump into the game, the prices go down. But of course, to put solar on a roof, you have to have a roof, right? And that automatically discriminates against lower income Californians and global citizens. It's much harder to get solar on your roof if you're a renter, or if you're living in a trailer park. Lower income individuals simply have a much tougher time. California is working hard right now with bills that allow you to change the story, and they're really innovative, but they take time. One of which is that there's no reason why the solar has to be on your roof. Why not have solar being deployed on large big box stores and malls, and you as an individual homeowner can choose, or maybe be induced, to buy a share in that solar farm. It offsets your electricity. It's not physically on your roof, but once the electrons go into the grid, it's really like eBay. It doesn't matter where it is, it's in the network. And so that's the kind of innovation that comes as you gain more experience. And those are challenges to think through how to make it happen. But that's really what gives people hope that it's not just solar energy on the roof of affluent people in California or elsewhere. It's finding ways to democratize it, to make it a tool for environmental justice, not a beneficiary of economic injustice. And that's part of this transformation. We've heard a lot of that. Just to highlight an example, this large green box is the total amount of arable land being in the United States. The amber box is the total amount of land we would need to devote to biofuels to meet 50% of our liquid fuel budget for vehicles. And this much smaller box is the amount of land we would need to devote to solar photovoltaics to get the same amount of energy. Now, you can't run your gas-powered car on solar, but that's why California is also the world leader in pushing for the deployment of electric vehicles. And the same challenge occurs. The initial programs to get electric vehicles into people's hands in garages, whether it's businesses or individuals, favors those who are affluent. Buying a Tesla or a Leaf or whatever else is something that clearly is easier the more affluent you are. So finding ways to change that story is what California is all about right now. Those challenges require people to recognize the wide range of benefits. One of the benefits that we don't quantify, we don't write down and take advantage of, is that every electric vehicle that is purchased and goes into use in an area with bad air quality is effectively a filter. Because you're taking a gas car off the road, or you're using it much less, and you're driving that electric vehicle with no tailpipe emissions. We'll get to the source of electricity in a bit. But every time you do that, the more electric vehicles you drive in areas that have bad air quality, whether it's Central Valley or Downey or City of Industry or places that have lower income populations on average, you are doing an environmental justice. You're using the clean energy technology to not only benefit our climate story, but also to directly impact people's health, as you heard from Linda. So California has a requirement, an objective, that we get to 1 million solar rooftops by 2020. When that was passed, people snickered, you're not going to get there. California just passed 500,000 solar rooftops. 2/3 of all solar rooftops in the U.S. are in California. And California has a target for 1 million electric vehicles in 2020. And we are about 220,000. So we're not as far, but when both of those are passed, people snickered. No one thinks we're not going to meet the solar rooftop target. And we have a lot of confidence that if we push hard and start coming up with not only ways to bring down the cost of electric vehicles, but clever new opportunities. For example, why not say if you buy a home or lease or you buy a condo or some other building, that you can write an electric vehicle purchase into the mortgage? You're effectively saying, I'm going to pay it off over the decades I'll pay off the mortgage. You're rolling it into another long-term purchase. We already do that for appliances, and after all, what's an electric vehicle but a big mobile appliance? So that's a new way of thinking, and it changes the equation. One of the concerns that utilities have is that if we all go solar, somehow no one's going to be left paying their bills, they're going to be up blah, blah, blah creek. On the other hand, an electric vehicle, that's like buying 2 to 3 homes of demand. So a way to turn the story around so that we benefit on air quality, we push this green energy agenda, we put a larger demand for clean energy on the road, is to subsidize by rolling into the mortgages those purchase of electric vehicles. And that's an example. And it doesn't have to be for homes, it can be for businesses, but it's an example of the kinds of policies that California is pushing ahead with. Now, I mentioned in the beginning, and I'll just conclude with a comment, that one of the big challenges has been that this seems to many people like a technical story. What's the cost? What's the performance of an electric vehicle, a wind turbine, whatever else? And that's part of it. And that's the part that gets a lot of attention. Most grants are available in that area. More people work on those topics where you kind of see the hardware aspect. But he's not the only one, but Pope Francis has highlighted in the encyclical on climate that this is really about behavior and choices about society. And I had the opportunity to work on the team inside the Vatican that drafted that document. And I can't say I was more pleased than anything I've done in a long time to get to interact with members of the Papal Academy of Science and of Social Science that 500 years ago excommunicated Galileo, that was now saying, we might have messed that one up a little bit. And they literally said that. And had a dialogue that doesn't solve the equation, but focuses directly on what are the aspects of our society, whether it's overconsumption, affluenza, whether it's not understanding that defiling nature is directly polluting ourselves, both in the global sense, but also in that immediate health sense that Linda so clearly laid out. And one of the biggest take-home lines from the encyclical was, we are turning the world into a great pile of filth. That's exactly the story you heard in the first lecture, where we have grown our economies dramatically on a system that worked economically but was mining the Earth's resources and was creating economic divides. And what I hope was kind of an understory in the comments so far was that we are now at a point where it's been a challenge, but we see the technical, the policy, and the behavioral opportunities to build not just the energy system that we happen to inherit, but one that we actually want for all of these other benefits as well as this climate story. So thank you so much for staying for the two talks tonight, and I look forward to the conversation.